plots. Construct the Bode plot for a unity feedback control system having g of s equals to 2000 divided by s into s plus 1, s plus 100. Determine omega gc, omega pc, that is gain crossover, phase crossover, and also phase margin, gain margin. Comment on stability. So what is the step 1? So we need to convert into a standard form. Okay, this we need to convert into a standard form. So step 1, we need to convert into a standard form. So g of s, h of s is a unity feedback. They have given unity feedback. H of s is value is 1. Write as it is 2000 divided by s, and here 1 plus s, and here 1 you will get here s divided by 100. Okay, so here or 100, so left is 20 divided by s into 1 plus s. It should be in terms of like this, 1 plus s into sp, 1 plus ts p1, 1 plus ts p2. So in the denominator we indicate poles, and in the numerator we indicate zeros. So it is the standard form. It should be in the form of like this. So in the equation what they have given in the g of s equation, it is not in the standard form. If it is in the standard form, no need to convert. Just if it is not there, then you need to convert like this by taking. So here what it is, here s plus 100, we want here 1 plus ts, like this it should be. So we need to take 100 as common, 1 plus s divided by 100. So what you will get, 1 plus 0.01 s. This is the step 1. So in step 2, factors we need to consider. The first thing is k. So it is a k value. Okay, k divided by s into 1 plus ts, 1 plus t2 tsp. Okay, like this it is. So this value is nothing but k. So k equals to 20. So 20 log k, that is 20 log 20 equals to, the value you get is 26.02 decibels. So straight line parallel to log omega axis or 0 axis, 0 dB. Okay. Next, second factor. You can observe here one pole is at the origin, that is s. Okay. So what we can write, 1 divided by s, one pole at origin, straight line of slope minus 20 decibels per decade. One thing you need to remember is, for poles we take minus 20 decibels. For if it is a 0, so plus 20 decibels. Okay, and one more thing, if it is a positive, okay, so for negative slope it will go on like this. Okay, sorry, for example, if it is a log graph, okay, so for negative slope you will get like this till omega equals to 1. Next, third one, another one, 1 plus s. Okay, so here 1 divided by 1 plus s, this is a simple pole. simple pole, and the T1 value is 1 here, 1 plus Ts. Okay, so the T1 value is 1 and the omega C1 value will be 1 divided by T1 equals to 1. So omega C1 equals to what we got? 1. Okay, so straight line of slope minus 20 decibels per decade for omega greater than or equals to 1. Next pole is 1 divided by 1 plus 0.01 s. So 1 divided by 1 plus 0.01 s. Okay. So this is a simple pole. T2 value will be T2 equals to 0.01 comma, and here omega C2 value will be 1 divided by T2. So 1 divided by 0.01 will be 100. So for this straight line, of slope minus 20 decibels per decade for omega equals to or greater than 100. So you need to write down the range of omega and resultant slope in decibels per decade. Okay. So range of omega is starting 0 less than omega less than 1, and next range is 1 less than omega less than 100, and the next is 100 less than omega less than infinity. So for this what we got is minus 20 decibels, that is at the origin, right? Next for next slope how much we got? Minus 20. So minus 20, and before what it is? Minus 20. So minus 40 decibels. And now so minus 40, and what about for this? So minus 20 again. So overall minus 60 decibels per decade. So next step 3. So till now what we have done, step 1, step 2, this is magnitude and magnitude Bode plots. Okay. Now we should calculate the phase angle table. Okay. So that is the step 3. So in step 3, S is replaced by j omega. So S is replaced by what? J omega. So G of j omega, H of j omega equals to 20 divided by j omega 1 plus j omega 1 plus j 0.01 omega. So we have replaced just S instead of S, j omega. So now we need to make a table. Okay. So I have written table omega and this one. Okay. So 1 divided by j omega, remember always, no need to calculate. 1 divided by j omega is 90 degree. So it is 1 divided by, if it is only in the numerator j omega, we will take positive. It is in the denominator, so minus 90 degree. And here tan inverse of imaginary part is omega and the real part is 1. So minus tan inverse of omega divided by 1 minus tan inverse of imaginary part 0.01 omega. Real part is the 1. No need to write divided by 1. Okay. So this omega value and this resultant angle. Okay. We want the angle now. So when you substitute omega equals to 1 here. Okay. So what will be the resultant angle you'll get is minus 135.57. Okay. So when you substitute and calculate minus 90 and tan inverse of 1 minus tan inverse of 0.01 into 1. So you'll get the resultant, overall resultant value is minus 135.57. Similarly, if you substitute 7, 20, 100, so what values you will get? Minus 175. If you calculate tan inverse of omega, tan inverse of infinity. So when you will get the tan inverse of infinity when it is 90 degree. So 90, 90. So minus 90, minus 90, minus 90. So you will get the infinity. Okay. So this is the phase angle table. So you can write if you want a phase angle table. Okay. Phase angle table. Now we need to plot the Bode plot. So in the log graph I have marked first phase angle. Okay. So phase angle minus 180 degree baseline. So first 180 degree dark line you need to mark. After that minus 150, minus 120, minus 90 like that. In down minus 210, minus 240, minus 270 like that. Okay. And similarly for magnitude also you need to start with a 0 dB line. This is the 0 dB line, dark we need to mark, and below you need to mark as here this line is plus 20 decibels. Okay. So sorry, minus 20 decibels. This is a plus 20 decibels and 40, 60 like that. Okay. So now I have marked K value. We got that 20. So that is so we have substituted the value, right? So after substituting the value, how much we got the K value in terms of decibels? 26.02. 20 log K value is 26.02 decibels. So K. Next, after marking this, so first minus 20 decibels. So one pole is at the origin. So what you should do is from here to and when omega equals to 1 till here. Okay. Till here you need to mark line. Okay. After that, for that parallel line you need to mark. Next, after marking one pole at the origin, that is one pole at the origin minus 20 decibels, I have marked here, and parallel for this. Okay, like this. So parallel line for this. Okay, after some distance. So this is value what we got is omega C1 equals to 1. So we have stopped here. So if it is value is different, for example omega equals to 2, omega C1 equals to 2, then we need to stop here like this. Okay. So omega C1 equals to 1 we got, so I have stopped here. Next continuation, omega C2 value how much it is we should check. Okay. So the omega C2 value is 100 we got. So we need to mark 100 till 100. Okay. So where it is 100 here. Okay. So we need to mark from here to 100. Okay. So now it is I have marked from omega 1 to 100. Next minus 60 decibels. I have written the condition C. Omega less than 1 minus 20 decibels. 1 to 100 minus 40 decibels. And from 100 to it is infinity minus 60 decibels. Now we need to mark the phase angle. one, what we got, the angle is minus 135. Okay, so minus 135, it will be somewhat here. Okay, when omega equals to 1, the angle is minus 135. It will be between minus 120 and 150. Okay, next, when it is 7. Okay, so when it is 7 means this is 2 and this is 3. Okay, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when it is 7, so what the angle we got is minus 175. So it will be near here. Okay, next, when it is 20, so this is the value 10 and here this is 20. So when it is 20, how much we got here? Minus 188. So minus 188 means it is cost this value. It will be here. Okay, next, when it is 100, so this is 100. So minus 224. So this is 210 line and it will be somewhat here. Okay, 224. When it is infinity, so we don't know, so it will be 270. Okay, it will be 270 line, 270. We don't know exact, so we should decrease, that's it. Okay, no need to mark, we should decrease the graph. Like this you'll get. Okay, I have joined all the lines. So now this line you should draw parallel somewhat. Omega c1, which we draw this line. Okay, omega c1. So after drawing this line, you mark which will cross the 0 dB line. Okay, it should cross the 0 dB line. There you mark 1 point. Okay, because this, if you put straight line, that is the value only omega gc value, and we can, if you put straight line here, the phase angle, for phase angle we get the phase margin. So which we have drawn one pole at the origin and parallel line. Okay, we will draw the parallel line that we have extended, right? So starting it was minus 20 decibels till omega equals to 1 and we have extended till 100, right? It should cross the 0 dB line. So wave it will cross at which value? Omega value it will cross, that is the omega gain crossover. Okay, and you should draw the straight line and here you'll get the phase margin. Okay, this how much from minus 180 degree line. Okay, this is a baseline from 180 degree line and this point. So how much angle it is? So this value is 12 degree. Similarly, so this phase angle graph which will cross the 180 degree line. So there also you need to mark and put the straight line. Then you will get the value of omega PC, that is phase crossover. Okay, this line is phase angle graph is crossing the minus 180 degree. Okay, so that is omega PC, phase crossover. Okay, so from here we got the 9. Okay, you can observe this phase angle graph is crossing after this will cross minus 180 degree. Okay, here it is joining 180 degree and after that it is decreasing. So here you should put a straight line so that you will get the value of omega PC and also the gain margin here. So we have marked this line, right, from 100. Okay, from omega c E1 equals to 1 to 100. Okay, so this line from here to and the 0 dB. Okay, from here to here. So how much the gain margin is? Plus 14 decibels. You cannot each is 4. Okay, because from you can observe from 0 decibels to 20 decibels there is a 5. Okay, so 1 2 3 4 5. So each will be 4. Okay, so somewhat exactly you cannot write, so somewhat some difference you can write, that is plus 14 decibels. Okay, so you came to know, right, how to find out the gain crossover, phase crossover, and the phase margin, gain margin. This is a easy to plot the Bode plot. So if it is a positive values, phase margin and also the gain margin, then we can say directly it is a system is stable. Okay, if it is a negative value, then we can say it is a unstable. Okay, so thank you for watching. Subscribe channel for the more updates. In next class we shall discuss with the another problem.